Chapter 8, 8b Review. Question number 1. f of x equals the square root of x minus 2 plus 1. So remember I asked you guys to take a look at the numbers that operates with the x, tells us it's going to move left or right. Numbers that's like a standalone number is going to tell you up and down. So x minus 2, so this 2 is inside the radical expression with the x. It is operating with the x, so this is telling us x minus 2, so 2 is a positive number. So you move everything right 2 unit. You move everything right 2, and this plus 1 is outside of the radical expressions. So if you move up 1, right 2, up 1, this is our new point of origin. From here, we do our count. Right 1, up 1, right 4, up 2, right 9, up 3. What kind of transformation do you see? As I mentioned before, it's right 2 because of this minus 2 positive number. Up 1, so this number is like a standalone number. It's not inside the radical expressions. So what's going to be our domain? So domain is the x values that's allowed. So when it comes to square root, think about the numbers coming out from your square root should be positive. So you have to set this x minus 2 greater or equal than 0. That's where you get the x greater or equal than 2. How about the range? Since you move everything up by 1, up 1, so this is telling you your y can never be less or equal than. The y would have to be greater or equal than 1. Question number 2. f of x equals the cube root of x plus 2. So this time, we do not see a number inside the radical expressions with the variable x. So nothing adding or subtracting from the x means our horizontally, there's no shift left or right. Plus 2, so this plus 2 is outside of the radical expressions. It's telling you move it up or down. So with positive number, it's going to move up 2 units. So from the point of origin 0, 0, I move up 2 points. So my new point of origin location is going to be located at 0, 2. There's no horizontal shift left or right again. X is not subtracting any number. So starting from this location, I do my count. Right 1, up 1, right 8, up 2. Left 1, down 1, left 8, down 2. Remember, this is a cubic root function, cube root functions. So I'm looking for the cube root. So once again, repeating the same information, what kind of transformation do you see? Because of this plus 2, I move everything up by 2. So what's going to be the domain? Since this is a cube root functions, there's no restriction at all. My x can be positive, negative, so there's no restrictions. So my domain is going to be x belongs to real number set. The corresponding y, the range, is going to be y belongs to any real number set. Question number 3. Y equals the square root of x minus 3 minus 2. So by this point, I'm assuming you are very comfortable using the transformations. Numbers operating with the x going to tell you left or right. Number outside the radical expressions is going to tell you up or down. So x subtract 3. 3 is a positive number, so we moved everything right 3 units. Subtract 3, right 3 units. Minus 2, so this number again is outside the radical expression. It's moving down 2 units. So our point of origin has been moved from 0, 0 to this new location, 3, negative 2. Right 3, down 2. From here, you do your count again. Right 1, up 1. Right 4, up 2. Right 9, up 3. What's going to be our domain? So once again, number coming out from your square root would have to be positive. So x would have to be greater or equal than 3. Range, so because of being moved down by 2, everything is being moved down by 2. So my y value would have to be greater or equal than negative 2. Question number 4. f of x equals the cube root of x minus 1 minus 2. So what kind of transformation do you see this time? X minus 1, so this one is inside the radical expressions, telling us it's going to move right 1 unit. So everything is being moved right 1 unit. Minus 2, so this subtracting 2 is outside of the radical expressions. you are moving everything down by 2 units. Right 1, down 2. From here, you do your count. Right 1, up 1, right 8, up 2. Left 1, down 1, left 8, down 2. What's going to be the domain? Since this is a cube root function, there's no restrictions. So my x, my input, can be any real number. What about the range? So again, this is a cube root function. Your x can be any real numbers, your y can be any real numbers. Question number 5. F of x equals the negative square root of x minus 3. So what kind of transformation do you see this time? Negative 3, I'll take care of this part first. It means moving everything down by 3 units. With the negative 3, it moves everything down by 3 units. How about the negative? So negative is telling me it's going to reflect. Since I move everything down by 3 units, the x-axis has been moved down by 3 units as well. So the new x-axis is going to be y equals negative 3. Reflect, so everything is being reflected. So how do I do the graphing? Starting from this new point of origin, 0, negative 3, I go right 1, I go down 1, I go right 4, I go down 2, I go right 9, I go down 3. Because of this negative, everything is being reflected down. So what's the domain? X can be any real number, and in particular, because of your square root has to be positive, so your x would have to be greater or equal than 0. Y, everything is being reflected down, so your y will not have a value. Y is going to be less or equal to negative 3. Question number 6. F of x equals negative square root of x minus 1 plus 4. So what kind of transformation do you see? With the minus 1, a positive number, x subtracting a positive number. So you move everything right 1 unit. Plus 4, so this 4 is outside of the radical expressions. So plus 4 means up 4. The negative, multiplying to the square root function, it means reflected across the x-axis. So again, what kind of transformation do you see with these particular expressions? Right 1, up 4, reflected across the x-axis. So how do I make the graph? Right 1, up 4 will become our new point of origin. Start from here, everything's being reflected. Right 1, down 1. Right 4, down 2. Right 9, down 3. What's the domain? X can be any real number, and x would have to be greater or equal than 1. What is the range? Y is any real number, and in particular, y is less or equal than 4. Question number 7. You are asked to rewrite the radical expressions into rational exponent form. When you don't see the index number, it's to assume it's read as square root of 17. So square root of 17 means the index is 2. I'll put the 2 at the denominator of my exponent. So again, if you don't see a number written, it's 2 assumed. So you have to put this number 2 at the denominator of the exponent. Rewriting from the radical expression square root of 17 into 17 raised to the 1/2 power. That's radical into rational exponent form. 17 raised to the 1/2 power. Number 8, the fourth root of 52. How do I rewrite it? So again, the index is the denominator of my exponent. So 52 raised to 1/4 power. Again, the index becomes the denominator of our rational exponent. Number 9. Now you are asked to rewrite the rational exponent back into radical expressions. So how do I do it? So the base becomes my radicand. It's going to be put inside the radical expressions. It's being raised to second power. So I'll put the second power with the x. And once again, the denominators becomes my index. So this is actually looking for the cube root of x squared. So in rational exponent form, it is read as x raised to the 2/3 power. In radical expression form, it is read as looking for the cube root of x squared. Number 10, 5 raised to the 3/7 power. Rewrite into radical expressions would be 5 raised to the 3rd power. The index comes from the denominators of your rational exponent. So this is looking for the 7th root of 5 raised to the 3rd power. Number 11, 81 raised to the 3/4 power. So the biggest hint comes from the denominators. We do not like to work with fractions. So look for the clue, over 4. How do I rewrite the numbers 81 into something raised to the 4th power? So I'm applying power of power properties. 3 raised to the 4th power equals 81. So I'm rewriting 81 into 3 raised to the 4th power. Now, a number raised to a power, then raised to another power, I multiply the exponent. 4 times 3 divided by 4, which is 12 divided by 4, that's 3. 3 raised to the 3rd power is 27. Number 12, 25 raised to the -3/2 power. So again, we do not like to work with fractions. So think about the numbers that you can convert to get rid of the 2. So from 25, I can think of 5 raised to the 2nd power. With this 2nd power, 2 divided by 2, so they can be reduced. 2 times -3 over 2, which is -3. How do I take care of the negative exponent? Whenever it comes to negative exponent, it's not a negative number. It simply means that I am putting it at the denominators. So 5 raised to the -3 power is equal to 1 over 5 raised to the 3rd power. And 5 raised to the 3rd power is 125. So the answer is going to be 1 over 125. Number 13, 8 raised to the 4/3 power. Rewriting the 8 into 2 raised to the 3rd power. So I can multiply the exponent. 3 times 4/3. 3 times 4, that's 12. 12 divided by 3, I have 4. 2 raised to the 4th power equals 16. Number 14, 4 raised to the 2.5 power. So again, I'm rewriting the 4 into 2 raised to the 2nd power. Power of a power property. 2 times 2.5 gives me a whole number, 5. 2 raised to the 5th power equals 32. Number 15, 8 raised to the 4th power, then raised to another -1/6 power. So this time, I multiply the exponent first. So 4 times -1/6 equals -4 over 6. Then I rewrite the 8 into 2 raised to the 3rd power. So I can multiply the exponent. 3 times -4/3, 4/6. So 3 times -4, that's -12. -12 divided by 6, that's -2. Again, with the negative exponent, I put the number at the denominator to get rid of that negative exponent. 2 raised to the 2nd power equals 4. So the answer for number 15 would be 1/4. Question number 16. 8 over 27 raised to the 1/3 power. So I rewrite 8 over 27 into 2/3 raised to the 3rd power. So again, the whole number, 2/3, is being raised to 3rd power. Then take the exponent, 3 times 1/3, that gives me 1. So the answer for number 16 would be 2/3. Number 17, 16 over 81 raised to the -3/4 power. Do the same thing like I did for number 16. 2/3 raised to the 4th power. So 2 raised to the 4th power equals 16. 3 raised to the 4th power equals 81. Multiply the exponent. 4 times -3/4, that gives me -3. So for the negative, I have to take the reciprocal. So I put the 2 at the denominator. I put the 3 at the numerator. Then raised to the third power gives me the final answer for number 17 as 27 over 8. 3 raised to the third power is 27. 2 raised to the third power is 8. Number 18. 8 times 27 raised to 2/3 power. So rewriting 8 as 2 raised to the third power. 27 as 3 raised to the third power. Then it's almost like distributing the exponent because it's inside the parentheses. So I'm distributing the exponent to each terms. So 3 times 2/3, that's 2. 3 times 2/3, that's 2. So I have both 2 raised to the second power, 3 raised to the second power, which is 4 times 9. That gives me 36. Question number 19. The square root of x minus 4 equals -5. So right at this point, can you ever have a number coming out from the radical expressions turn out to be a negative number? So it's almost like giving away points. When you see the square root equals a negative number, there won't be a real number for the x to satisfy the equation. So the solution for this one is no solutions. Basically, no solutions when it comes to a square root equals a negative number. Number 20. The cube root of x minus 4 equals to 2. So, how do I undo the functions for the x? When it's cube root, I think of being raise it to 3/3 power. So I cube both sides. Cube root and cube, they cancel each other. They are the inverse function of each other, so they cancel each other. To the left-hand side, I have x minus 4. To the right-hand side, 2 raised to the third power equals 8. X equals, so I add 4 to both sides. 4 plus 8 is 12. Don't forget to plug your numbers back in to check your answers every time. Check, check, check. Question 21. -9 equals -3 times square root of x minus 2 plus 6. So, by subtracting 6 to both sides, I have -15 equals -3 times square root of x minus 2. Divide both sides by -3. 5 equals square root of x minus 2. Undo the square root by square both sides. So raised both sides to the second power. Square root and square cancel each other. So now I have 5 raised to the second power, which is 25. Square root and square cancel each other. I have x minus 2. Add 2 to both sides to find my x equal to 27. And once again, don't forget to check your answers. Question number 22. 4 times square root of x minus 3 equals 36. Divide both sides by 4. Square root of x minus 3 equals 9. Square both sides to get rid of the radical expression, square root. Square root and square cancel each other. So I have x minus 3 equals 9 raised to the second power is 81. Add 3 to both sides. I have x equal to 84. Once again, don't forget to do your check by plugging in 84 back into the equation to see if the statement, the equation, true or false. Question 23. -2 equals 2 times square root of x minus 6 minus 10. Add 10 to both sides. -2 plus 10, I have 8. 8 equals 2 times square root of x minus 6. Divide both sides by 2. 8 divided by 2, that's 4. 2 divided by 2, I'm left with square root of x minus 6. Square both sides to get rid of the square root symbol. 4 raised to the second power, that's 16. Square root and square, they cancel each other. So I have x minus 6 on one side. Add 6 to both sides, x equal to 22. Once again, don't forget to do your check by plugging in x equal to 22 back into the equation. Question number 24. Square root of 3x minus 1 equals the square root of 2x plus 4. I'm going to square both sides to get rid of the radical expressions. 3x minus 1 equals 2x plus 4. Subtract 2x to both sides. To the left hand, I have x minus 1. To the right hand, I have 4. Plus 1 to both sides to find x equal to 5. And one last time, don't forget to do your checkings by plugging in x equals 5 back into the equations. Question number 25. You're given the function f of x equals x minus 2 over x minus 3. So for this particular equation, I would like to rewrite it into the form with x minus 2. I'm going to write it as x minus 3 plus 1. Because I want to make the numerator the same as my denominators. I'm writing you all the steps so that it's clearly for you to see. X minus 3 plus 1. Minus 3 plus 1 equals the negative 2. So then I can separate the functions into x minus 3 over x minus 3 plus 1 over x minus 3. In particular, x minus 3 can be reduced down to 1 plus 1 over x minus 3. And this would be the form of what we are familiar with. So I'm just rewriting it so that the x minus 3 is telling us this number, minus 3, is operating with the x. It's telling you move left or right. So subtracting a positive number means that I move everything right 3 units. And then this plus 1 is not operating with the x, so it is moving everything up by 1 unit. Right 3, up 1. So the information that is asking you for 0 and wholes, I'm just going to mention it briefly here because we did not discuss this in class. 0 means that where the graph crosses the x-axis, 0, y equals 0, so that means the 0. When x plugs into the function, it'll make the function equal to 0. So when x equal to 2, so in particular, as you can see here, x equal to 2, 2 minus 2, that's 0. So that's why it's called zeros. Are there any wholes? So since the functions does not have a numerator and the denominators have the same common factors, so there won't be any whole. We will discuss this more if you decide to take on the pre-calculus. We'll mention this in more details. From here, what are the vertical and horizontal asymptote? So when it comes to rational expressions, make sure you put down your horizontal vertical asymptote. So as we move the point of origin from 0, 0 to 3, 1, mark it down horizontally, vertically. This should serve as our guideline. The graph should never crosses these two lines. From here, I have 4, 2 as my first point, right 1 up 1, right 2 up 1 half, right 3 1 up 1/3, right 1 half up 2, right 1/3 up 3. And then do the same thing for the negative part. Left 1 down 1, left 2 down 1 half, left 3 down 1/3, left 1 half down 2, left 1/3 down 3. Question number 26. F of x equals 1 over x plus 1 minus 2. So how do we graph these functions? Again, this number x plus 1 is operating with the x. So this is telling us moving left or right. I have to rewrite this into x minus negative 1. So x subtract a negative number, negative 1, I move everything left 1 unit. Minus 2, so again, move everything down. So starting from the point of origin, left 1 down 2. Mark down your horizontal, vertical asymptote once you locate your point of origin. From there, we do our count. Left 1, right 1 up 1, right 2 up 1 half, right 3 up 1/3, right 1 half up 2, right 1/3 up 3. Do the same thing for the left hand branch. Left 1 down 1, left 2 down 1 half, left 3 down 1/3, left 1 half down 2, left 1/3 down 3 to complete your graph. Again, the quickest way for you to graph these rational expressions would be to locate your point of origin. Left 1 down 2. Mark down your horizontal, your vertical asymptote to help you serve as the guideline that the graph will never crosses it.